Assalamualaikum and good day. My name is Muhammad Azli Hakimi bin Azhan, and today I will be presenting our group project titled Cloud-Based Smart Assignment Submission and Automated Notification System using AWS. Our group consists of me, myself, Muhammad Azli, Muhammad Haikal, and Muhammad Nasrul. Although I am presenting on behalf of the group, each member contributed to different technical components of the system. This project provides students with a secure platform for submitting actual assignment documents. The document is stored in a private Amazon S3 storage. The submission information is recorded in the DynamoDB. The lecturer is notified through Amazon SNS, and backend activity is monitored using Amazon CloudWatch. Conventional assignment submission may require the lecturer to check multiple platforms, organize documents manually, and record submission information, and repeatedly check whether the new work has been submitted. This process may become inefficient when managing many students and assignment documents. Therefore, our project aims to automate the submission, storage, recording, notification, and monitoring process by integrating several AWS services. The main objectives are to create a working web-based submission platform, securely store actual documents, automatically record submission details, and send an immediate lecturer notification and monitor back-end processing errors. The responsibilities were divided among the three members, as me myself are responsible to develop the student web page using HTML, CSS, and JavaScript. These include the interface design, student input fields, drag and drop file selection, front-end validation, and S3 static website hosting. Muhammad Haikal are responsible to configure an Amazon API gateway and develop the AWS Lambda backend. These include the post-submit route, the prepare upload and complete upload process, the pre-designed S3 upload URL, and back-end validation. Muhammad Nasrul are responsible to configure the private S3 assignment bucket, DynamoDB table, SNS notification, CloudWatch logs, metric filter, and error alarm. All members participated in the system integration, troubleshooting, testing, and documentation. This diagram shows the complete architecture of our system. The student accessed the submission web page hosted using Amazon S3 static website hosting. The web page sends a pre-upload request to API gateway, which invokes AWS Lambda. Lambda validates the student information and document details, generates a unique submission ID, and returns temporary pre-signed URL. Then, web page uploads the actual PDF or doc or docx document directly to private S3 assignment bucket. After the upload, the web page sends a complete upload request. Lambda verifies the S3 object, stores its metadata and object location in DynamoDB, and publishes an SNS notification through the lecturer through email. CloudWatch records the Lambda activity, while the CloudWatch also monitor backend processing errors. Now, I will proceed with the live demonstration in AWS. I will now demonstrate a successful assignment submission. This web page is hosted using Amazon S3 static website hosting, which is this one. So now I will begin by entering their full name and student ID, which is, for now I use Adam, number, and I just select files. CPS ROM, and the file shows the current size of the file. And then now I will click the submissions. So when I click this submit assignment, the web page first requests a temporary upload URL through API gateway and Lambda. Lambda validates the request, creates a unique submission ID, and generates the temporary pre-signed URL. The actual bucket is then uploaded directly to the private S3 bucket. And finally, Lambda verifies the uploaded object, the record the submission in DynamoDB, and then send the lecturer notification through SNS. Then now you can see on the screen the assignment has been uploaded successfully. The result shows the unique submission ID, accepted status, and also file name and also file size. I will now use the submission ID to verify the same transaction across the AWS services. This is the private Amazon S3 assignment storage bucket. Inside the assignment folder, each submission has its own folder based on their unique submission ID, which is from here you can see 4169. So it's matched the unique submission ID, and here we can see the actual PDF document was submitted through the web page. It can be opened or downloaded through the authorized AWS console. Block public access is enabled for this bucket, so the normal public object URL return access denied. This document is also protected using server-side encryption with Amazon S3 Managed Keys or SSE S3. This is the matching record in the assignment submission dynamo table. The partition key is the submission ID. The record contains of file name, the student name, submission time, submitted form, student ID, status, S3 object key, subject S3 bucket, file type, and file size, and also file name. The DynamoDB stores the submission metadata and the location of the document. The actual document itself remains inside the private S3 bucket on the Amazon S3 storage bucket. After Lambda successfully verifies and records the submission, Amazon SNS automatically sends an email notification to the lecturer. These emails contain the submission ID, student ID, file name, file size, file type, submission time, status, and also where it actually stores the actual file. This also allows the lecturer to know that immediately when a new assignment has been successfully submitted. I will now demonstrate the first validation test directly through the AWS Lambda console. This test simulates a request containing a unsupported PNG file. The test event contains valid student information, but the file name is assignment.png. The system only permits a PDF, doc, and .cf documents or PDF. Okay, now we'll click test. Is executing function started, and the details. The Lambda function executes successfully, but the request return status of 400 with an unsupported file type message. This means the application correctly rejected the document during the back-end validation. Because the request failed validation, the Lambda function did not generate S3 upload URL. Therefore, no document was uploaded to S3. No submission record was created in DynamoDB, and no normal SNS submission notification was sent. This is an expected validation rejection rather than an unexpected system failure. The second validation test checks the maximum file size limit. This simulates the request contain a valid PDF document but its declared size 11 megabytes. The system only permits the document up to 10 megabytes. Okay, now we click test. Now it already succeed. The Lambda function returns status 400 with a message stating rejected. The request was rejected before the S3 upload process. Therefore, no pre-assigned upload URL was generated. This test demonstrates the system prevents oversized document from entering the upload process and avoid unnecessary cloud storage processing. The unsupported file and oversized file types are expected validation failure, so they should not activate the CloudWatch error alarm. To test backend error monitoring, I will intentionally send malform JSON directly through the Lambda test function by using this code. This malform request causes a JSON processing exception inside Lambda. Now I will press test. Now the test is successful. Show the request body content invalid JSON and the status rejected. The Lambda invocation may be shown as successfully executed because the function handled the exception and returned an HTTP 400 response. However, the function also records the custom message error processing submission in CloudWatch log. The CloudWatch metric filter detects this message and increase the custom error metric. In the CloudWatch log stream, successful processing produced a message such as upload URL created and submission success. The intentional malform JSON test generated error processing submissions. So the metric filter detect the error message. Once it's evaluated, the alarm change from OK to in alarm. So you can see here, so it will send a message. The alarm is connected to a separate SNS topic named Smart Assignment Error Alerts. As shown here, an automatic error alert was sent after the CloudWatch detect the back-end error. This demonstrates a proactive monitoring because the administrator can be notified without manually checking every log. Amazon API gets away provide the post-submit endpoint used by the web page. The Lambda backend contains two main actions. The prepare upload action validates the input, creates the submission ID, generates a safe S3 object key, and returns a temporary pre-signed upload URL. The complete upload action verifies the actual S3 document, store the submission information in DynamoDB, and publish the SNS lecturer notification. Configuration values such as the DynamoDB table, SNS topic, allow website origin, file size limit, and upload bucket are stored as Lambda environment variable. You can see this is the site, the SNS topic ARN, table name, and upload bucket. Several security measures were implemented. The assignment storage bucket is private, block public access is enabled, and documents are encrypted using SSE S3. The pre-signed upload URL is temporary and does not expose AWS credentials or provide permanent bucket access. API gateway and S3 cost settings are restricted to the official website origin. Required fields, file extension, and the 10 MB limit are validated on both the front end and back end. One major challenge was uploading the actual document without making the S3 bucket public. This was solved using the temporary pre-signed URLs. Another challenge was configuring CORS correctly between the website, API gateway, and private S3 storage. In conclusion, our project successfully integrates Amazon S3, API Gateway, AWS Lambda, DynamoDB, SNS, and CloudWatch into one automated cloud application. The system securely uploads the actual assignment documents, record the submission details, notify the lecturer automatically, reject invalid submission, and send an alert when a back-end processing error occurs. Therefore, the project achieved its main objective and demonstrates effective integration of AWS services within the AWS Learner Lab environment. Thank you.